Hello everyone, so today we are solving the fifth question of the CSES problem set. So this question states that we need to print a permutation in which there are no adjacent elements whose difference is 1. So this is a constructive type of problem where there is like we need to think upon it and come up with a solution that is quite natural, or that I must say that comes with the practice. These type of questions are asked in code forces div 1 and code chef, sorry, code forces div 2. A question will be something like this only. So let me just tell you the solution for this. Yeah. So what I thought, when I initially read the problem, I thought it like, what if I have a test cases 3, and since if any solution does not exist, we need to print no solution, and here we have given 3, and no solution is printed here. Okay. So first of all, let's think of the edge cases. Now, since n is less than equals to 1, so 1 can also be a good test case. But since 1 is given, then we need to print 1. So this is one of the edge cases we need to think upon. Now, what if 2 is given? So if 2 is given, so there are only two permutations possible, 1 2 and 2 1. And both of these permutations are not fitting to the definition of what we are told here, beautiful. These both the permutations are not beautiful, since there are adjacent elements existing whose difference is 1. Now let's come to 3. Now since adjacent difference should not be 1, so permutations like 1 2 3 and 3 2 1 simply got eliminated, and there is, now we need to think differently. So initially I thought of printing like first odd numbers and even numbers. Since if I print first odd numbers, then every element will have a difference, every adjacent element will have difference of 2, and in even numbers also there is a difference of 2. So in for if for this test case I do like first print odd even numbers and then print odd numbers, so it's giving me 2 1 3. But here also this is not possible as shown in the test case. It is given here that for 3 no solution is there. So if I, for example, show 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2, 3 2 1. So these are the 6 permutations possible, and we can see like every permutation there is a combination where two adjacent elements exist whose difference is 1. So no solution is possible for this. But what if for the 4, I think about my logic of odd numbers and even numbers. So if I start with even 2 4 and 1 and 3, so there does not exist any number. And also, since this number will always be greater than 1, since we have handled it for 1, like I must say this must always be greater than 3, since we have handled the cases for 1 2 and 3. So this will be greater than equal to 4. So this number, uh, either odd or even, will always be greater than 1, and uh, it won't form any adjacent difference with 1, since it will be always greater than 1. And in this sequence I can say like all the numbers coming will be at the difference of 2 only. So here also I don't have any problem, and since this is the maximum number, and between 2 and 4 whichever numbers will be there, they also form a beautiful sequence here. So this is the core logic of the problem. Like we just have to prove that 1 and the last number ending here of the even series will always have a difference greater than 1. So I hope I am able to prove this. Let's just code it up. So first I will take the input n, scene n, and if n is 1, let's handle the test cases cout 1 and we will directly return from here. Now if n is less than equals to 3, cout no solution and return. And now for the rest of the cases, what we are going to do, we will first print the even. For int I is equals to 2, I less than equals to n, I plus plus. If I mod 2 is 0, cout I, and then we will print odd starting from 1. I is equals to 1, I less than equals to n, I plus plus if I mod 2 cout I. Yeah, so let me check it for some test cases. See, first even and then odds. Okay, so now I must submit this and check if it is running fine on the other test cases as well. Yeah, so as you can see, it got accepted. Now other way which I am trying just now, like what if we will just reverse and print odd first and even first. So I think that should also work. Yeah, so this one should also work if I print odd first and then even. Let me check for some test cases. Yeah, so here also the same logic. No, this won't be working for 4, but since 3 and 2 are coming together, so that's why the logic, our previous logic was correct. Since 3 is ending and 2 is starting, all the even series are starting with 2. So for the test case 4, we need to handle separately, and after that the next number will always be 5, which will be greater than 2. So yeah, so below above 4, this one will work, and we can write for 4 separately. Let's check if that gets accepted. I am writing the sequence for 4 separately. So 2 4 1 3 with a space, not comma, and I will turn. Okay, so for 4, wait, something went wrong. If the input is 4, then the sequence is 2 4 1 3, and if 5, then it will be starting with odds 1 3 5 2 4. Yeah, so I think this should also get accepted. Yeah, this also got accepted. So this was it for today's video. Thank you.